everyone. Today I kind of want to go back to basics and talk about something that I think is really important for version control, almost necessary, and that is a commit. I think a commit is a very simple concept that it can be very easy to grasp, but also has layers of complexity. And I think if you understand those layers, then it will make you more confident and also could answer a lot of the questions that you might have. At least I had them and I got them answered. I wanted to share them with you. So that's what we're going to do today. I think it would be interesting to kind of start with a definition. You may be comfortable with commits or not. I think it's interesting to make sure that you do because I feel like we work a lot with commits in our day-to-day as software engineers, but we don't really take the time, at least I didn't take the time to actually think about what's going on behind this and what is actually a commit. So a commit is a way to save a state of your repo. So every time you make changes to your repo, you can save this into a commit and you will be able to see the state of your repo at that point in time. And I think that's pretty interesting because it's kind of a timeline almost where you can see your repo, changing over time. So that's what a commit is. I tried to find a way to explain commits and show you how to properly do commits in the easiest way possible, and I narrowed it down to 4 commands. Yeah, I think if you get the hang of these 4 commands and you can do them naturally, then I think you will be very confident and you will have an easier time working with version control, especially as a beginner. Because I've been through this, I was having a really hard time, and working through them, practicing with them, but also understanding what they did helped me a lot. So that's what I'm going to try to do today, and these are the commands. So I'm going to go through one example that will cover all of them because they all tie together too. They all tie to commits at the end of the day, and I want to show you how so that it's easier for you to visualize what this all means. Let's go through an example. Now we're in the project that I just created, and I'm going to create a Git repository inside of it with this command, and then we initialized an empty Git repository right here, and we can see that we're on the main branch. We're going to stay on the main branch. We don't need to go too crazy. It's not about branching, it's more about committing. And so to make a commit, you need a Git repository, right? So that's what I did. I set up myself to be able to make commits. Now I have my project, and my project is completely empty. I just created it. So my goal now is to actually do something, right? We want to create a file. We want to make a change. We want to change the state of my repository. So I'm going to create a file called hello.py. It could be anything. And I'm going to write hello from YouTube. And I'm going to save this. Here we go. So now we can see that we have the hello.py file. Now let's say I finished editing and I want to save those changes. It's pretty simple. We have to commit this, okay? But let me start with something. The 2 commands that we saw earlier. So git status and git log. Now this is where they come in hand. I'm just going to hit git status. Okay, what happens? We have some information on branch main, no commits yet, untracked file, and then we have that hello.py that we just created, okay? Now what git status does is just give you the status of your repo. It's pretty simple, right? And it tells you a little bit of information about your repo, and especially what you want to look for is the untracked or tracked files. This is where you know what files you made changes to and which are the ones that are tracked, okay? Now tracked doesn't mean committed. It means added to the staging area. Now adding a file to the staging area is the thing you have to do before you commit a file, okay? Because you can't just take a file and commit it. You have to add it to the staging area first. And adding it to the staging area kind of tells the Git repository, oh, don't, just so you know, I want to add this file to my commit. And the reason that you want to do that is because sometimes you don't necessarily want to commit all the files that you've changed, right? Some of them maybe you don't care about, or it's just for local development, and you don't want to add them to your commit. So you have the freedom to add specific files to the staging area, and then the commit will know which ones to save, essentially. And then we also have that git log command. We're just going to hit that, okay? And then it gives me an error. It gives me, your current branch main does not have any commits yet. That's true, we do not have any commits, and git log will just give you the history of commits. That's pretty much it. Since we don't have commits, nothing shows up. But that will change because we're gonna have to make a commit now. So the first thing that we have to do, as I said, is add the file to the staging area. So to do that, we just hit git add, and that's the third command that I showed you. So you're going to add the path to the file, so that will just be hello.py, and that's it. Now, if we do git status, what do you think will happen? Here you go. It's tracked now. It's in green. Do you see the difference? That means it's tracked. That means it's added to the staging area, and that if you make a commit, this will be saved. So the only thing that we have to do now is commit. And the commit command is pretty simple, and it always comes with a message, which is why I put the -m. And then you put your message in quotes. And your message actually gives more details as to what your commit is doing. So I would say create the hello file. And that's it. Now we can see details here, okay? We can see that one file changed and one insertion. That means that we created the hello.py file. And we can see the committer is me, and that's pretty much it. Those changes are committed. Now, what if we do git log? Isn't that interesting? Now we have something. We have that commit that we just made, create the hello file. And that is how you make a commit with these 4 simple commands. You could just commit and add. That's pretty simple, but I think the status and log help me a lot to visualize what is actually happening behind the scenes and what files are tracked, what files are not, because sometimes it was not very clear to me what was happening, and this helped me a lot. I think these 2 commands are complementary to the commit command, and I think they're very interesting to use, especially as a beginner. Now, that part is done. I've told you how to make a commit. I think practice makes perfect. Now, this was the part that I think was important to practice, okay? But I want to go even deeper. I want to uncover those layers, and I want to show you where those commits are actually stored, because it's very easy to know what a commit is, but not really understand how Git was made and where those commits are stored and how they work. And I think that's a very interesting part of Git, and I want to show you that. So that part is not really, that you don't really need to learn by heart or anything. You wouldn't use it at work, but I just think it makes you more confident, and it also answers a lot of questions that I think you may or may not have. But it's great to have those answers, in my opinion. So we're gonna get to the bottom layer of this, and let's start with how a commit is stored. So I don't know if you've noticed, but if we do git log and we see that commit that we made, we can see commit and then a long string right here. Now, you may have wondered what this string is, or you may know what the string is, but essentially it's called a SHA. And a SHA is a unique identifier of a commit. So all commits have unique identifiers, and they're all based on the input of the commit and the author and the date. So all SHAs are built upon this information. They're not just randomly generated, they're actually encoded based on the information of the commit, and that's how they become unique. Now, it's a very long string, but I can also show you this. When you commit something, you will see these 7 little characters that form a string, and they're actually the commit SHA, but shortened. And the short version of 7 characters is also valid to recognize a commit. So I'm actually going to show you where that commit is stored, because when you look in your project, you can say hello.py. You don't see where the Git repository, like where does everything get stored? That was a big question mark for me. And actually, we have a .git directory inside of your project that is hidden. If we go into the .git directory, it will bring you in it. And you will have a lot of things inside of it. Now we're going to focus on the objects section because this is where the commits are stored. They're in the objects section. So if we go into objects and we check what's inside of it, then we will see some things. What does that even mean? 070B34 info pack. Well, I'm just going to do this. I'm going to copy the 7 characters that we saw and paste it here. Do you notice anything? Do you notice anything weird? Well, if you noticed, the 3-4, the first 2 characters, are the same as this 3-4. And actually, that's how commits are stored. They take the first 2 characters of that commit and they create a directory with it. And then inside of that directory, they will store the commit with the rest of the string of that SHA. If we go into 34, which is a directory, and we check what's inside, you will see a long number. Now, if we do git log again, and we check that number, and we quit out of that, I'm just gonna paste it here. It's exactly the same minus the 3-4 because that's left for the directory. But as you can see here, we have the same SHA, and that's where the commit is. Now, I want to go and get to the bottom layer of this. So let me cat into that file, right? Let's see what's going on inside of that file. Now, that doesn't look like my commit, or it doesn't look like anything actually. Like, what is this? Well, it's actually your commit, but it has been compressed, and it's not really something that humans can understand. But it is your commit. And so there is a specific command that you can do to actually make it pretty so that you understand. So that command would be cat file -p and then the same number. Yeah, and don't forget to add the 3-4. Okay. And there you go. You have the information of that commit. Now, that seems like it's not enough information for me. Like, I don't even know which files were changed. I don't even know what's inside of that file. I have no idea of the actual state of my repo, right? That gives me some information of the author, the committer, and the message, but really nothing else. Although, we can see a little thing here called a tree with a long string again. Now, we fall into another kind of niche aspect of commits. So, a tree is equivalent to a directory, and that's how commits are stored. They create a tree of a directory, and then if you have multiple files inside of your repository, then they're stored into that tree, into a directory. So that's the equivalent of it. So we can see that for this commit, we have one tree, and that's the unique identifier of that tree. Now, what if we run the same command again on that tree instead of the commit? Then we see something else that's pretty new. We can see that hello.py, that's the only thing that's familiar to me. Hello.py, that's the file that we changed. I guess we're getting somewhere. And then we can see a blob right here. What's a blob? A blob is the equivalent of a file. So a tree is equivalent to a directory, and then a blob is equivalent to a file. So as you can imagine, if you have a lot of files in your repository, you will all find them here. Now we have only hello.py, but if we had multiple files, they would all show up here. And we have another string. Now, okay, that's good. We can see that we have a hello.py, but we can't see inside of it. I want to get to the bottom layer. So I'm just going to run exactly the same command again. And here we go. We can see what's going on and what has changed inside of that file. And that's hello from YouTube. And that's pretty much it as to how files are stored into a commit. So as I told you before, a commit does not store just like changes it stores the entire state of the repo. If we go back and we create another file called buy.py, and we say buy from YouTube, and we save that, and then we add that to the staging area, and we commit this, we can see now 2 commits. What's going to happen if I go check where that commit is stored? What will I see that will be different? So now we're in, and pretty much everything is the same, but we see something different, parent. And I don't know if you remember, but it's the same SHA number as that first commit that we made. And so that's what happens when you create that kind of like commit tree. That commit has a parent, and that parent was the commit that we made before. But let's go deeper, okay? Let's take that tree again. So that's different. We have 2 blobs. That makes sense, right? Because we have hello.py and buy.py. But as I said, it doesn't store the changes, it stores the entire state of the repo. So even though we didn't make change to hello.py, it is still present in the commit because we want to see that it is present. So it's a whole state, it's not the changes. You can even change 1 letter in 1 file and it will save the entire state of the repository inside of that commit. Now, I hope that helped to clear some questions, to help you know how to make a commit, but also maybe to make you a little bit more curious about Git, because I was curious about Git and that's how I got into it. All right, well, I think that's it. Thank you so much for being here and listening. I hope that helped in some way. I hope I helped you understand a little bit more of the deeper layers and the complexity of a commit. Even though it's a simple concept, I think it's a pretty interesting one. Thank you so much, and see you in the next one.